Addition and subtraction of fractions are a little more involved than multiplication and division. Normally we learn addition and subtraction first, and then multiplication and division later. Multiplication is repeated addition. So we need to know addition to do multiplication. But for fractions, addition and subtraction is a little more involved. But it all comes down to just a matter of counting things. That's the idea of addition and subtraction. So let's say we had 1/5 and 3/5. And we're asking here, how many fifths are there? Well, in the first one, we have 1/5. And if we add that to how many we have in the second one, which is 3/5, well, if we have 1 and 3, that means there's just 4/5 there. And that's the correct way for doing it. That's because we're talking about the same portions. We're talking about fifths here. Okay? What happens if we talk about different portions? For instance, 1/2 plus 2/3. Now we could say, well, you have 1/2 here and 2/3 there. 1 plus 2 is 3. But what's the denominator? Is it 2 or is it 3? Is it some combination thereof? That's kind of the issue with addition and subtraction, is that if we're not talking about the same portions, then we need to redefine the numbers we're working with to have the same portions. And this changing of the denominator is kind of like a remeasuring. We do this by trying to find what's called the least common denominator. The least because the smallest number is easiest to work with. You can find any common denominator and add it, but you're going to be adding a lot more work for yourself. So we always go for the least common denominator. So in other words, we're going to look at the multiples of 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 10, 12, and so on. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, and so on. And you see here, we do have common numbers in both of these. We want to always use the least common multiple, which we're going to make the least common denominator, because that's going to make us have easier work in the end. So what I'm going to do is I'm going to remeasure, quote unquote remeasure, these fractions having a denominator of 6 instead of the denominator it has. So for the first fraction, 1/2, 2, which is the denominator. 2 times what is 6? 2 times 3 is 6. Whatever we do to the bottom, we have to do to the top. If we don't do that, then we're actually going to be changing the number itself. And that would change the problem, and then you'd be doing a completely different problem. All right. For the second problem, 3 is the denominator. So 3 times what is 6? 3 times 2 is 6. So we're going to multiply top and bottom by 2. Now, the first one is 1 times 3 on top. 2 times 3 is 6. And the second one is 2 times 2 on top. And 3 times 2 is 6. And now you see we have the same portions on bottom, right? They're both out of 6 now. And we can do just like we did in the previous problem. If we have 3/6 in one hand and we have 4/6 in the other hand, how many sixths do we have? Well, we have 7/6. You'll notice that in both of these problems, we are not adding the denominators, right? This isn't 7/12. We're leaving the denominator the same because that's kind of the reference portion, right? We're referencing sixths. That's how many we're adding up. The numerators are what we are adding, the 3 and the 4. So really you could say that 3/6 plus 4/6 is 3 plus 4 sixths. And that gives us that answer there. That's how addition and subtraction actually work. we need to get common denominators. And the best one to get is the least common denominator. Then the operation is done. And the final result always needs to be simplified. 7 6 can't be reduced, so there's nothing to do there. But we could, if we wanted to, write this as a mixed number. Right, 6 can go into 7 once. 7 minus 6 is 1. So we get, 7 6 or 1 1 6, whichever one the question requires. I always tend to just leave as improper because it's easier to do, but sometimes mixed numbers are necessary. All right, here's another problem that we want to add, and we need to have common denominators to do it first. There are, in my mind, there's 3 ways. There's probably more than that, but there's 3 ways you can find common denominators. And depending on how comfortable you're doing, any one of these ways works. Some of them are faster, some of them take a little bit more work, things like that. The first way is what I showed you last time for the last problem, which is write up the multiples of these numbers. 8 times 1 is 8, times 2 is 16, times 3 is 24, 32, 40, 42, so on. We get 6, 12, 18, 24, 30, 36, 42, and so on. And here you can see that we have 24. That's going to be the least one. There's also 42 as a common multiple. So we know that we can get denominators of 24 in both of these fractions. Doing so would make us do this. We would do 5. So I guess 5 times 3 is 24. And 6 times 4 is 24. And we can go on with the rest of the problem. Let me show you the next way, which actually first, let's actually solve this. We get 15 over 24 plus 28 over 24. Now we have 15 24ths, and then we have 28 24ths. So how many 24ths do we have total? We have 15 plus 28, which would be 33, 43. I was saying 20. It's 43 24ths. That's how many 24ths we have in total. And this cannot be reduced, so you can leave it like this, or you can make it into a mixed number, whatever the problem requires. Now, the next way of doing it, and this will always work no matter the problem. However, this tends to be the worst way of doing it because it gives you the most work you typically have to do. You can always get common denominators, not necessarily least common denominators, by multiplying by the other denominator. So this denominator, let me do it like this. This denominator is 8. I'm going to multiply this by 8. This denominator is 6, so I'm going to multiply this one by 6. And do it on top and bottom, of course. Now you'll see that both denominators have 8 times 6 in the denominator, which means we'll get 40, let's see, that's 48. That's my problem here. This is supposed to be 48 up here. And this one should be a 48 over. Sorry if you saw that and you were wondering about it. My bad. There should be 48 in both of the denominators. And so we get 48 over 5 times 6 is 30. And this one is 48. 7 times 8 is 56. That gives us 86 over 48. And now we have to reduce. Both of these can be divided by 2. Which gives us 43 over 24. The same answer we got previously. So that will always give you more work because, well, not always, but typically multiplying by the other denominator won't give you the least common denominator. Now, the last method is a little more advanced. It's one where if you're competent with numbers, then it actually ends up being probably the fastest method, because you really start understanding how to work with these numbers the most. So I'm going to take 5/8 and let's see, 7/6. And I'm going to look at what is the prime factorization of 8. This is based on what's called the fundamental theorem of arithmetic. Every number, every positive number, has a unique prime factorization that only it has. And so prime numbers are like 2, 3, 5, 7, 11, and there's infinitely many of them. But every number can be broken down into these prime numbers. 8 is the same thing as 2 times 2 times 2. Every single one of those things that are multiplying is a prime number. 2 is a prime number. It's the only even prime number. 6 is 2 times 3. 3 is a prime number as well, and 2 times 3, of course, is 6. So these are the prime factorizations of 8 and 6. 2 times 2 times 2, and 2 times 3. Now, what we're looking to do is we're trying to get the same numbers on both fractions. So we're kind of asking, what does one have that the other one needs, and vice versa. This one has a 3, so I need to multiply this by 3 on top and bottom. Now, this one has 1 2, so we don't need one of these 2's, but this one has an additional 2 2's, right? So the additional 2 2's means we need to multiply by 2 of them on here. And you'll notice that on bottom here, let me just erase some of these extra lines so it doesn't get confusing. On bottom here, we have 2 times 2 times 2 times 3, and 2 times 3 times 2 times 2. We have the same number of 2's and the same number of 3's in both fractions. And that means that they are going to be the exact same number. 2 times 2 times 2 times 3 is 2 times 2 is 4, times 2 is 8, times 3 is 24. And we get 15 over 24 plus 28 over 24, which gives us 43 over 24. And you'll notice this first method that we did here and this last method give us the kind of the fastest way of doing it. We don't have to reduce necessarily at the end. Some problems you do regardless, but the first method uses multiplication, like actually listing out where we do these things here, these multiples here. And the last way you use the prime factorization to find the same thing. Now, there's the 3 methods here, and each one of them works. So do whatever one makes sense to you. I like the last method. I think it's the when you get really good at working with these kinds of numbers, the last method tends to be the fastest, but it does take some practice. The first method is probably the most kind of easiest to get into using, so I kind of recommend that method when you're not when you're just kind of starting off. The second method helps when you just have no idea what to do. So do whichever one makes the most sense to you. I do want to talk about this prime factorization method here, this last one, just a little bit, and try to understand how do we find these prime factors, this 2 times 2 times 2 and this 2 times 3. The method's not complicated. So for instance, if we had 60, what's the prime factorization of 60? We do this what's called factorization tree. We just say what times what equals 60, and you can do anything. I like to use prime numbers though, and I always use like the smallest one, namely 2, whenever I can. 2 times 30 is 60. 30 then is 2 times 15. Now 15 can't be divided by 2, but the next smallest prime number is 3. 3 can go into 15, 3 times 5. And here we can stop. 2, 2, 3, and 5 are all prime numbers, which means the prime factorization of 60 is 2 times 2 times 3 times 5. Just multiply those numbers together and you'll see you will get 60. And 60, that's 60's unique prime factorization. Let's look at another one. 33. The smallest prime that can go into there is 3. 3 times what is 33? 3 times 11. And actually 11 is prime as well. So 33 is 3 times 11. That's its unique prime factorization. Let's look at 105. I can definitely see 5 going into there. I'm not sure of any other prime number. 3 can, but 5 is the one that stood out to me the most. So I'm going to start with 5. 5 times 21. 21 is 3 times 7. And these are all prime numbers here. So we have 3 times 5 times 7. You don't have to write it in least to greatest, but I like to because it keeps it ordered. So that's kind of prime factorization. Now, you don't have to write down only prime numbers. Let's take 60 again here and look at it separately. 60 is the same thing as 20. We can do like 15 times 4. You can do 20 times 3, but 3 is a prime number. I wanted to show you something that did not have prime numbers. 60 is 15 times 4. Now, neither of these are prime. And we can find more numbers that can go into both of them. 15 is 5 times 3. Now, both of those are prime, so we can stop there. 4 is 2 times 2. And both of those are also prime numbers, so we can stop there. You can, however, keep going. You don't have to just, like, if these are not prime numbers, you can just, like, break them down further. But since they are prime numbers, they don't break down further. And of course, you see we get the exact same prime factorization. 2 times 2 times 3 times 5 as this above one here. So you always get the same factorization no matter which way you do this. Let's move on to find some least common denominators so we have practice with that. Say we have 2 and 5. What's the least common denominator, or LCD, of 2 and 5? Well, you can do any one of the 3 methods. 2 is, the multiple of 2 is 2, 4, 6, 8, 10, 12, so on. 5 is 5, 10, and there we can stop because 10 and 10 are in both of those things, which means the least common denominator, that's the smallest multiple it's in both, is 10. So we're going to do 2 times 5 and 5 times 2 if these were in a fraction, which they aren't. We're just trying to find the least common denominator as some practice. So 8 times 10 is the next one. Least common denominator, we can do 8, 16, 24, 32, and 40. And I can actually stop there because 40 is going to be the least common denominator. 10, 20, 30, 40. You can see that. When you're good with multiples of numbers, then you may not even have to write it all out like this. You should be able to tell, you know, what the least common denominator would be pretty quickly. All right, let's go on to 9 and 30. Nine, 18, 27, 36, 45, 54, 63, 72, whoops, 72. Need a little more room here. 81 and 90. And that's going to be, you're going to see that that's going to be the least common denominator. 30, 60, 90. That's the common in both of those things. So 90 is the LCD. Now this one, you had to go quite a ways in 9. So this one might be actually a good one to look at in a different way. We could do the prime factorization. Definitely don't want to do the other one, the like 9 times 30. That's definitely not going to be the least common denominator in this case. But let's break down 9. 9 is 3 times 3. And that's the prime factorization right there. 3 times 3. Both of those are prime. This 30 is 3 times 10, and 10 is 2 times 5. So 9 is 3 times 3, and 30 is 3 times 2 times 5. So what would the least common denominator be here? Let me erase that so I'm mathematically correct. Well, the top one has 2 3s, right? We have 1, 2. The bottom one only has 1, so we're going to need another 3 there. The bottom one has a 2, the top one doesn't, so we're going to need to multiply by 2. And the bottom one has a 5, the top one doesn't, so we need to multiply by 5. And now you see that both of them have the same numbers, 2 3s, 1 2, and a 5. Multiplying this out, we will get 90 for both. And so that way we found that's actually faster than writing out these multiples. All right, this is definitely true when we have numbers like this. 108 and 72. These numbers are large, and we might be able to find the multiples pretty quick, but we can do it even faster probably with the prime factorization. Let's just do that real quick to give you experience in doing that. 2 times 54 is 108. 2 is prime, 54 is not. 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. And you can see these are all prime numbers here. So 108 is 2 times 2 times 3 times 3 times 3. 72 is 2 times 36. 2 times 18. Oops. 2 times 18, not 3 times 18. This is 3 times 6. And this is 2 times 3. 2 times 2 times 2 times 3 times 3. And now we can see, what do we need? This one has 2. This one has 1, 2, 3. So this one needs an extra 2. This one has 3 3s. This one only has 2 3s. So this one needs an extra 3. And that will get us the correct least common denominator, which is 2 times 2 times 2 times 3 times 3 times 3. Doing that gives us 216. Both 72 and 108 can go into 216, and that's the smallest number they can both go into. That's what the least common denominator means. Okay, with a little bit of practice like that, let's actually do some addition and subtraction problems. See how they go. This one should be straightforward. They have common denominators, so all we need to do is add the numerators. And 12 over 12, that's just 1. All right, 5 6 plus 1/4. We do not have common denominators here, so we need to get them to be common denominators. What is the least common denominator? What can both 6 and 4 go into? If you know your multiples, both 6 and 4 can go into 12. So we're going to do 6 times 2 and 4 times 3. 5 times 2 is 10, 6 times 2 is 12, 3 times 1 is 3, 4 times 3 is 12. Now 10 twelfths plus 3 twelfths, that must be 13 twelfths. And I'll leave it as an improper fraction. Great. 47 50ths minus 3/10. Now subtraction is done the exact same way addition is. Get common denominators first. Okay, what can both 50 and 10 go into as a least common denominator? And actually 50 is the least common denominator. So the first fraction we don't have to change. The second one, if we multiply by 5, you'll see we get 50 in the denominator. 3 times 5 is 15, and 10 times 5 is 50. Now all we have to do is just subtract the numerators. 47 minus 15 is 32. And this needs to be reduced. 16 over 25. And that can't be reduced anymore. So that's going to be our answer there. Again, if you're not sure, how to find the multiples, just do one of the 3 methods I showed you before. The listing out the multiples is kind of what I'm doing here. I just know the multiples of 6, 4, 50, and 10. It's the ones that are weirder that become more necessary to do these, actually write these strategies out. All right, let's do 3 7/8 plus 1 5/8. Now there is a method for adding mixed numbers together. And you need to first get common denominators in the fractional part. The problem is that doing this requires multiple steps and can sometimes be tedious. If the numbers are small, this one's actually not too hard to do. If the numbers are small, it's fine. But when they become very different, the fractional part becomes very different, it becomes a lot more tedious, and it's easier to just convert this to a mixed, an improper fraction first, and do the process we've been doing. I'll show you both here. This one's not too hard because both of these things have an 8 in the denominator, which means they're already measured in the same portions. Okay? So to add these things, we're going to go 3 plus 1 is 4. Because we're adding these whole number parts. Now we can look at the mixed number, or the fractional parts. 7/8 plus 5/8 is 12/8. Now this isn't the correct answer because a mixed number is supposed to be a whole number with a fractional proper fraction. Okay? It needs to be proper. In this case, we have an improper fraction, so we need to make it into a proper fraction. Now this is actually the same thing as 4 plus 12/8. That's what a mixed number is. It's just a fancier way of writing that. And 12/8 is, by its own nature, a mixed number. What is the mixed number? It's going to be, how many times can 8 go into 12? It can go in there once. 12 minus 8 is 4. We get 4/8. And now you see we have 4 plus 1 is going to be 5 and 4/8. And of course, the fractional part, 4/8, can be reduced, right? We can divide top and bottom by 2. Giving us 5. Sorry, not by 2. We can divide it by 4. You can divide by 2, but you're going to have to divide by 2 again. But if we divide by 4, we get 5.5. So this is the mixed number part. Like I said, there's a lot of steps to that, and it can be confusing if you're not comfortable with it. What can be easier, at least maybe not easier, but more like following the methods we've already learned, is to change this to a mixed number, an improper fraction first. Your normal strategy here: 8 times 3 is 24. 24 plus 7 is 31. So we get 31 over 8 plus 8 times 1 is 8 plus 5 is 13. 13 over 8 here. Now these already have common denominators, so we can add the numerators. 31 plus 13 is 44. And we can reduce. We can reduce by 4 on top and bottom. (11/2). And now we can ask the question, because we started with mixed numbers, let's end with mixed numbers. So we can ask the question, how many times does 2 go into 11? It goes in there 5 times. 5 times 2 is 10. 11 minus 10 is 1. So we get 5.5. And I think this bottom way is faster actually in this case. The top way does work, but it can be prone to error if you're not sure what you're doing. The bottom way I think is a little bit cleaner to work with. So that's what I would recommend, is changing first to improper fractions. Okay, let's look at 22 and 16/17 plus 4. So this way is actually fastest to just do the mixed number, because here we have 2 whole parts here. 22 plus 4 is 26 and 16/17. That's because the 22 is how many total parts there are, and there's 22 total parts or whole parts, and 4, there's 4 whole parts there, which means the fractional part doesn't even come into play because we already have these whole parts written as a number. Now this only works when you have a mixed number plus a whole number. If you're unsure, you can just change these both into fractions, right? We can change them into improper fractions. This one's going to be a bit large because all these numbers in this mixed number are large numbers. 17 times 22 equals 374. Plus 16 is 390/17. Plus 4/1. We have to get common denominators. That's quite easy. This just needs a 17 on top and bottom. 4 times 17 is 68. Now we can add those numerators. 458/17. And of course we can change back to a mixed number. 17 can go into 458 how many times? I see 26 whole times. I got 26.9411, and then it continues on. So we know it's 26 whole times. 26 times 17 is 442. So we go 458 minus 442, and that gives us 16. We get the same thing both ways. So definitely the top way in this case is much easier. 1 1/2 minus 7/10. Let's change this to a improper fraction. Gives us 3/2 minus 7/10. And what's the least common denominator of 2 and 10? It's going to be 10. 2 times 5 is 10. 3 times 5 is 15. 2 times 5 is 10. Minus 7/10. 15 minus 7 is 8. This can be reduced by 2 to get 4/5 as the final answer there. So here we're taking 4 separate pieces of wood with these measurements, and we're allowing for 1/2 inch of waste, and we're asking what length of a long piece of board can we cut up to get all of these measurements for these pieces. So we're going to have 5 3/8, 8 1/4, 6 9/16, and 2 5/8. And we're allowing for 1/2 inch of waste as well, because when you cut the pieces, right, some of it comes off as sawdust, so you need to allow for waste. To find the length of the total board that we're going to cut up into these 4 parts, all we have to do really is just add these all together. If these are all the lengths and we add the waste onto there, then we should get these measurements when we cut it all up. Now we can do this multiple ways. These aren't too hard to do just by adding the mixed numbers together. We can make them all the same denominators quite simply because of the measurements. 2, 4, 8, and 16. These are all divisible by 2, and they're not too hard to work together. We can also change this to mixed numbers, to improper fractions first and add them up, then change back in the end. Either way works. I can show both. Let me show you probably the longer way in this case is to change them to improper fractions first, but it's also the method I think that's the most straightforward. It's you kind of know what to do. I'm doing it this way, so I'm going to change all these to mixed numbers first. 8 times 5 is 40 plus 3 is 43 over 8. 4 times 8 is 32 plus 1 is 33. I add some space there for extra parts. 16 times 6, can't think of that off the top of my head, that's 96. 96 plus 9 would be 105. 8 times 2 is 16, plus 5 is 21. And then 1/2 is 1/2. Now we need to get common denominators. And hopefully this is clear that 16 is the common denominator here. 2, 4, 8, and 16, right? These are all just multiples of 2. And all of them can go into 16. Quite simply, right? 8 times 2 is 16. 4 times 4 is 16. 16 times 1 is 16. 8 times 2. And 2 times 8 is 16. So now we get 86 over 16 plus, let's see, 132. Okay, that's what I thought. Wanted to make sure. 105 over 16, 42 over 16, and 8 over 16. So now you see we do in fact have common denominators here. So all we have to do is add the numerators. I'm going to use a calculator. I'll make it much faster. 132, 105, 42, and 8. That's given me 373. Over 16. We were given mixed numbers to start with, so let's end with a mixed number. 373 divided by 16 gives me 23 point something, which means we have 23 as a big number. 23 times 16 is 368. So we go 373 minus 368, which gives us 5. We have 5/16 left over. So that's how many inches of a long board we need to make sure we can cut up to these smaller portions. Let me show you the other method real quick. The first thing I want to do here is I want to get the denominators to be the same. I'm going to make them 16. That one's fine. This one's times 2, and this one's times 8. Now what we get is 5 and 6/16 plus 8 and 4/16 plus 6 and 9/16 plus 2 and 10/16 and 8/16. We can add together the whole numbers. 5 plus 8 is 13, plus 6 is 19, plus 2 is 21. And now we can add the fractional parts. 6 plus 4 is 10, plus 9 is 19, plus 10 is 29, plus 8 is 37. We have 21 and 37 sixteenths. Of course, 37 sixteenths is an improper fraction. We need to change it to a proper fraction. 16 can go into 37 twice. So we have 21 plus 2. And if 16 go in there twice, 16 times 2 is 32. So 37 minus 32 is 5. So 37 over 16 is the same thing as 2 and 5 sixteenths. Now we can add the whole numbers again and get 23 and 5 sixteenths, which is the exact same thing as we got in the other problem. Which, I mean, that should be, right? They should be the same thing. Either way works. If this method makes sense to you, do it. This problem actually made it a little bit easier, I think. But this method up here is the one that I would tend to do because it's more straightforward. I understand it, and I'm less prone to errors using this method. Here we have a piece of like steel or something with a hole drilled in it. And we know the whole piece is 6.5 inches long. And we know that this first piece here, just in case it's not clear, this is the portion we're looking at. This is 4 7/8 inch long. And we're asking, what is A for this portion right here? Find this. All we have to do is take off 4 7/8 from 6.5. That's the same thing as subtracting these two numbers. That's going to give us the measurement of A. So I'm going to change this to mixed numbers, improper fractions first. 2 times 6 is 12, plus 1 is 13. We get 13 over 2. 4 times 8 is 32, plus 7 is 39. Now we need to have common denominators here, and the common denominator between 2 and 8 is 8, because 2 times 4 is 8. 13 times 4 is going to be 26. 52 minus 39 over 8. 52 minus 39 is, let's see, 13, I think. Yeah. And we started with mixed numbers, so let's end with mixed numbers. 13 over 8, 8 can go in there once, and there's 5 left over. We got 1 5/8 of an inch. I will say that doing this the other way, whereas we work with just the mixed numbers, subtraction becomes a lot more work because we need to start thinking about taking parts of the whole number and adding it to parts of the fractional part. It becomes a lot more convoluted. I recommend whenever you have a subtraction with mixed numbers, change them first into improper fractions. I believe you'll be less prone to error, as I am.